How's it going? Good? Good, good, good? Beautiful weekend. Are there any questions on the material that we've just had a homework assignment on that was about determining the mood and figure of a categorical syllogism and using that mood and figure after looking it up on a chart to figure out whether or not that syllogism is valid or invalid? Questions? If you do have further questions but you don't want to ask them right now, catch me after class. We should have a little bit of extra time at the end of this session. Or you can follow me back to my office and we can talk about it in my office. Let's back up just a little bit. Boom. That's where we were at our last meeting, right? This is our old familiar chart that all of those medieval monks were kind enough to make for us. And we know that if we determine the mood and figure of any categorical syllogism, I can look to see on this chart if it's there. Of the 256 different possible combinations and permutations of mood and figure, 15 of those are what are known as unconditionally valid. We also have this additional 9 conditionally valid syllogistic forms. Didn't get into that at our last meeting. What the difference between those two are, we're not going to get into it at this meeting either. But Wednesday, we're totally going to get into the difference between conditionally valid and unconditionally valid syllogistic forms. So this is a decent method. It's a little bit wonky because you have to rely on the idea that the chart is already accurate. Maybe you're a trusting sort of person, and you're like, yeah, sure, no mistakes were made here. Also, it requires that you always have this chart with you. And you might not always have this chart with you. You could put it on a card and laminate it and keep it in your wallet, which I'd recommend. That's a good thing to do. But what if you lose it? Then you're lost, right? You'd have to look it up on the internet, on your phone, like some kind of heathen. So you could, actually I would say, yeah, these days, maybe this is a decent method. You'll always be able to look it up. But I think you can understand this stuff better if you don't have to use this method. Additional strategies that we can use involve things like this. So this is the way the medieval monks did it. Instead of having this chart that was always available to them, this was back in the day. So people's memories were a little better. We just had to use our memories more back before things were readily available on our phones. So there was a poem that these monks would use to try to remember all of the valid syllogistic forms. Barbara celerant Dariae ferioque prioris. That's the first line of it. And that means, these are just all names. Barbara, celerant, Dariae ferioque. Those 4 prioris, they're first. And what this means is the first figure, figure 1, the valid forms are Barbara, celerant, Dariae, and ferioque. What? Like Barbara is not actually Barbara is a syllogistic form. And the reason why we call it Barbara is because the vowels are A, A. So A, figure 1, valid. Celerant, E, E, figure 1, valid. A, figure 1, prioris, valid. Ferioque, E, figure 1, valid. That's how this poem works. Wouldn't that be cool if I required everybody to memorize it? If you are interested in this sort of thing, I'm offering an extra credit, 10 points on any of your exams. Just pop into my office sometime. This includes online students. You'd have to pop into my office sometime, do it. If you can't come into my office, maybe we'll figure out some other way to make sure that you're not cheating. But pop into my office sometime, sit down with just a blank sheet of paper, and give me that chart of 15 unconditionally valid syllogistic forms, 9 conditionally valid ones. Or you could use this method. This method is 5 rules, and you would take any syllogism and run it through these 5 rules, and if it passes all of those tests, then it's valid, and if it fails any of them, it commits some sort of formal fallacy. This would be an interesting one to get into because it gives us a different sort of understanding of how to think about categorical syllogisms. But we might notice, for example, rule number 1 says the middle term must be distributed at least once. And if we don't do that, then it's invalid and it commits the fallacy of undistributed middle. In order to explain that, we'd have to explain what it means to distribute a term, and maybe that's just a little bit excessive. It is another method that you can use to determine whether or not a categorical syllogism is valid. We're not going to look at it because I've got another method. I think 2 methods is enough. The look it up on the chart one and this other one that we're going to talk about, 2 methods is plenty for this. And the other one that we're going to look at today is more interesting, easier to remember, and it builds on something we've already been looking at, Venn diagrams. So we're going to use Venn diagrams in order to determine whether or not categorical syllogisms are valid. We've already used Venn diagrams to represent the content of a single categorical proposition, like all SRP, right? We know how to do an all SRP Venn diagram. We know how to do a no SRP diagram. We know how to do a sum SRP Venn diagram. We know how to do a sum SR not P Venn diagram. I know Venn diagrams for my A, E, I, and O statements. The only thing that's going to make this more complicated is that we're dealing with more statements now, because I have an argument with 2 premises and a conclusion. And I'm dealing with more than 2 terms, because anytime I have any categorical proposition, every single categorical proposition is talking about exactly 2 categories, a subject term and a predicate term. The only parts of a categorical proposition that there are the quantifier that tells me how much of the subject term I'm talking about, the subject category, some copula, and a predicate category. But in an argument, in a categorical syllogism, I have more than 2 terms. I have 3 terms. I have a major term, a minor term, and a middle term. So my Venn diagrams are going to necessarily be more complicated. 1, because I have to represent the relationships between not just 2 terms, not just S and P, but now S and P and M, my middle term that's relating them. And we've hopefully already noticed that this is every categorical syllogism is some statement about my major term relating it to my middle term, some statement about my minor term relating it to my middle term, and then that middle term acting as a link between my major and minor term, so that in my conclusion I can give you a relationship between the major and minor term. And that's proven, hopefully, by the premises that were on offer before. So, my Venn diagrams are necessarily going to be more complicated because I am dealing with 3 terms instead of 2, and because I'm going to have to try to diagram multiple statements at the same time. And that's what we're going to learn today. First, let's just try to make this less scary than it looks maybe on its surface. This is not that complicated. This is the same concepts as any of our Venn diagrams, just kind of instantiated on a slightly more complex level. So this region 1, the light blue up there, that's just all the things that are M's that aren't S's or P's. That's all that is. All the things that are M's that are S's are here in zone 2 and 3. If it's an M and it's also an S, look, zone 2 and 3 are both in the M circle and also in the S circle. So zones 2 and 3 are M's that are S's, but there's a difference between the ones in zone 2 and the ones in zone 3. Zone 2 are the M's that are S's that are outside of the P circle. So zone 2, these are things that are M's, they're also S's, but they're not P's. Zone 3 are all of the things that are M's and S's and also P's. Zone 3 is all of the things that are all 3. They belong to all 3 of the categories. Over here in zone 4, those are all the things that are M's that are P's but aren't S's, and so on and so forth. You get how this works? I don't need to do it for every single region. You get the idea. There's a convention that I'm going to insist that we follow, at least until we're really, really strong on this. And that convention is minor term in your syllogism, always down here, bottom left. Major term in your syllogism, boom, always over here on your bottom right, and your middle term always on top. So let's always do this in terms of 3 circles, 1 on top, 2 at the bottom. The one on the bottom left is my minor term, the subject of my conclusion. The one on the bottom right is my major term, the predicate of my conclusion. And the circle on top is my middle term. And they should all be intersecting like this. You'll get some practice drawing 3 circles that intersect perfectly. Cool, cool, cool? All right. So, first, let's recognize that this is not really all that much more complicated than what we've been doing already. If I want to do an A diagram in this horrible, complex, nasty mess of 3 circles, all I need to recognize is that any given A statement is only ever talking about 2 things. I have 3 circles on this Venn diagram, but I'm only going to be talking about 2 of the categories. So for all SRM, I'm talking about S's, I'm talking about M's, but I'm not talking about P's at all. So just forget that the P circle is even there. Just ignore it. Ignore it. Do one of these. Cock your head a little bit to the left. And we'll see. I have an S circle and I have an M circle. Just 2 circles. They're interlinked. And all S or M is shading out this crescent moon or Pac-Man shape over here, the region of S that's outside of M. When I shade that out, I say nothing lives there. So everything that's left that is an S has to be inside the M circle. That's exactly the same as the all SRP, or all of the A Venn diagrams that I've seen before. We've already had an assignment on this. We've already practiced doing Venn diagrams for A statements. That's a Venn diagram for an A statement. Just like every single other one that you've ever seen, it's just turned on its side and there's an extra circle drawn over the top. Get it? Ooh, way less enthusiastic nodding on that. Let's look at one more. I don't know if that'll make it easier. But all MRP, I do have to pay attention. I do have to recognize like what it is that I'm talking about. I do have to have some sense of like, what is the content that I'm representing? I do need to note that like I'm talking about M's and P's here. I'm not talking about S's, so just forget that that S circle is there. But here's all my M's, here's all my P's, and if all M's are P's, I need to shade out everything that's in M that's outside of P. This kind of Pac-Man or fat crescent moon shape. So that the only things that are left available in the M circle are also in the P circle. That's all M's or P's. That's the same all M's or P's, the same all S's or P's. It's the same A statement that I've done before a million times. In fact, it looks exactly the same as that Venn diagram. It's just that the positions are moved. Because instead of saying all S's are M's, now I'm saying all M's are P's. Or I could say all P's are S's, in which case I'm only talking about the P circle and the S circle. Forget the M circle. And notice that if all the things that are P's are S's, that means I have to shade away all of the non-S P's in a fat crescent moon or Pac-Man shape, just like I do with an A statement any other time. Does this make sense? Somewhat. It's exactly the same as diagramming an A statement, but now I'm recognizing that that A statement could be between any of the 2 circles, between any of the 2 terms that are in this 3-term, more complicated Venn diagram. I can do this for E statements as well, right? For an E statement, I'm going to shade, but I'm not going to shade that Pac-Man shape. I'm going to shade more of a football shape, right? I'm going to shade that region where the 2 categories in question are intersecting. So if any E diagram, like no M, R, P, again, I'm talking about M's and P's. I'm not talking about S's or at all. So just forget that circle. Pretend it's not there. No M's or P's is going to take this entire region of things that are both M's and P's, and we're going to say that doesn't exist. Shade it out. So that's no M's or P's, where I've shaded out the region where M and P intersect. Here's no S's or P's, where I've shaded out the region where S and P intersect. Here are no S's or M's, where I shade out the region where S and M intersect. And it's exactly the same as any other E Venn diagram that I've done before. I'm just moving it around this more complicated structure. Does this make sense? At least approximately as much as the last one made sense? Okay. Hopefully we're feeling strong on this, because the next step introduces a little bit of a wrinkle. What is the next step? I've done A diagrams, I've done E diagrams. Yeah, I and O diagrams. I and O diagrams, I'm not shading, I'm Xing, because it's a particular statement, right? And for particular statements, I'm always saying there exists at least one thing that is here in this particular place where I draw my X, right? Where this becomes more complicated now is when we recognize that, for example, let's take a look here at sum SRP. My sum SRP Venn diagram says there exists at least one thing that's an S that's also a P. So it's got to go in this intersecting region, this football-shaped region between S and P. There exists something here. That's what sum SRP tells me. But because I have a third circle on this Venn diagram, we'll notice that some of this region of things that are both S's and P's, some of them are in the M circle, but some of them are out of the M circle. When I say that sum SRP, which is to say there exists at least one thing that is an S that is also a P. Is that thing an M? Is it not an M? Do you know? Yeah, you don't know, right? You have no idea whether the some existing thing that's an S that's also a P is an M or isn't an M. And because you don't know, you can't arbitrarily represent it as one or the other on your Venn diagram. You have to put it on the line. To put it on the line is to indicate that, like, it could be that this is inside the M circle. It could be that it's outside the M circle. I don't know. This is important. I don't know whether that X is in or out of the M circle. Does that make sense? So same thing going on here. For some S are not P, I know that there exists at least one thing. It's definitely an S. There are some S. And it's definitely not a P. So there's definitely something that's inside the S circle that's outside of the P circle. But I don't know whether it's inside or outside of the M circle. So I have to recognize that, like, both of these regions are S's that are not P's, but I'm not sure whether some S's are not P's refers to things on this side of the line or on this side of the line, so I put it on the line. How you feeling? Good? And if we just do it, same thing. Same thing over here, right? Some M are not S. There exists at least one thing. It's definitely an M. It's definitely outside of the S circle, but I have no idea whether it's inside or outside of the P circle, so it has to go on the line. If we can do this, I think we've got almost everything we need in order to use Venn diagrams to determine the validity of a categorical syllogism. Basically, all we do is we start representing the content of... did I skip it too far ahead? No, that's exactly where I'm supposed to be. All I need to do is represent the content in my premises on my Venn diagram. So if I have a categorical syllogism like this, all M are P, some M are S, therefore some S are P, the first thing that I want to do with this is I want to do a Venn diagram of my premises. I want to represent the content of my premises on my Venn diagram. This happens to be an AII3 syllogism. Does that make sense? Is this in standard form? Let's double check. Standard form, P is my major term. There it is in the first premise, good. S is my minor term. There it is in the second premise, good. Conclusion comes last. That's standard form. So this is an A, I, and my middle term is the subject both times. That's figure 3. That's an AII3 categorical syllogism. If I was inclined to, I could look that up on my chart and tell whether it was valid. But if you like surprises, don't look yet. Let's see if we can do it without using the chart. So all MRP, all MRP. Here are all my M's, here are all my P's. I'm not talking about my S's, so forget about that. Shade out everything in the M circle that's outside of the P circle. All that's gone. So now the only things that are left that are M's are also P's, or all M's are P's. Then I have some M are S. There exists at least one thing that is in the M circle that is also in the S circle. Now, this is interesting. If I had tried to do a Venn diagram of this statement first, my sum M R S statement first, I would have said, this region's inside the M and the S circle, and this region's inside the M and the S circle. These sum M that are S's, are they P's? Are they not P's? Do I know? I don't know, so I would have put my X on the line. But since my all MRP statement tells me to shade this region, nope, that X doesn't go on the line. To go on the line would say I don't know if it's on this side or on this side, but when I shade this region out, I say there is nothing on that side of the line, so it's got to go. For this reason, we usually say always diagram your universal statements first. Always do your shading before you do your Xing on these Venn diagrams, because you might shade out a region that'll help resolve some ambiguity about where an X should go. You might not have to put an X on the line if you can rule out one of the possible zones by shading it in one of your other statements. Does this make sense? And if it doesn't make sense, just believe me, always shade before you X on these Venn diagrams. Because you might end up shading out a region where you've already X'd, and then that's trouble. All right. So AII3, All m's are p's, shade that out. Some m's are s's. The only place that I can have an m that's still an s is in zone 3 right there, so I put an x. And then I put down my pencil and I walk away. Don't draw anything else on this Venn diagram. Only ever, bless you, only ever diagram your premises. For today at least. Wednesday we'll learn one more new little trick, but for today, diagram your premises and then put your pencil or your pen or whatever down. Because what we're looking for now is whether I've already diagrammed my conclusion. I'm testing for validity here. Somebody remind me, what does validity mean? An argument is valid if what? Premises.
They can't be false.
The premises can't be false?
Well, it's
I thought it was the conclusion would be true if the premises are true.
If the premises are true, then the conclusion would have to be true, right? Yeah. So telling me my premises should be enough already to know for sure that my conclusion is true, right? This is what we're doing with this Venn diagram. We're saying if I diagram the content of my premises and the conclusion is already diagrammed, that means that if the premises are true, the conclusion has to be true. If I have to add more to my Venn diagram in order to see my conclusion, more beyond what my premises have told me, then I need more than just my premises to get me to guarantee the conclusion, right? And that's not valid. A valid argument is one where your premises are enough for you to know for sure that your conclusion must be true. So, yep. Yeah, have we done this? Sure. This syllogism is valid. I don't have to add anything else to this Venn diagram. I just have to step back and notice that I've diagrammed all M or P by shading this region out. I've diagrammed some M or S by putting an X there. And now I step back and I say, have I already represented some S or P? Is there some existing thing that's an S that's also a P on this diagram? And yeah, there is. It's that X right there. That X is in the S circle. It's also in the P circle. There exists at least one thing that's an S that's also a P. I know that this syllogism is valid just by diagramming its premises and noticing that I've already diagrammed its conclusion. If I can't do that, if my conclusion isn't anywhere to be found without adding more stuff to the diagram, invalid. The argument's invalid. My premises aren't enough to guarantee my conclusion. How you feeling about this? A little extra practice? Remember this. Never, never, never. Never actually diagram your conclusion. You need the conclusion to already be there in order to prove whether or not that argument was valid, whether or not that categorical syllogism was valid. You are only ever diagramming your premises and then stepping back and waiting to see if the conclusion's already there. Yes, Daniel.
Now, doing that, you proved that it was valid, but will that tell you whether it's unconditionally valid or conditionally valid?
We are not messing with conditional or unconditional validity just yet today, but yeah, exactly. That's the next little wrinkle, and it's actually going to involve tinkering with my Venn diagram a little bit after I've diagrammed the premises. If we have a little bit of time today, I'll show you what it looks like. And there are some Venn diagrams on our worksheet today that are conditionally valid, but not unconditionally valid. So we'll run into that a little bit today, but we'll clear it up on Wednesday. Let's try some of these. IAI1. If you want to be the sort of person that reads the end of the book before you read the whole book, you can go ahead and check on the chart to see if IAI1 is valid or not. If you want to do it more, the more surprising and educational way, we'll look that up after. Let's start with this. Some M are P, all S are M, therefore some S are P. That's IAI1, an I statement, an A statement, an I statement. It's in standard form. And it's figure 1 because my middle term is the subject in my major premise and it's the predicate in my minor premise. That's figure 1. IAI1, is that valid or is it invalid? How are you going to figure this out? Yeah, do a Venn diagram. Do a Venn diagram. So it starts with 3 circles. Go for it. In your notebook. 3 circles drawn. 2 on the bottom, 1 on the top. Bottom left is your minor term. Bottom right is your major term. And the top one is your middle term. In fact, here, I'll even draw a blank one here for you so that you have some sense of what it should look like. Should look like this, right? It might take you a couple of stabs to like make sure that the intersections are all reasonable looking. But yeah, you should have this kind of like three-leafed clover type thing. It's trillium looking business in the middle. Which one of those two premises do you want to try to diagram first, by the way? Some MRP? Raise your hand if you want to try to do some MRP first. Raise your hand if you want to try to do all SRM first. A whole lot of people on that second option. Why? Because you want to shade before you X, right? Because you might end up shading, you might end up like placing your X in a region that gets shaded out later. So let's shade first. Always do your universal statements first. So first do all SRM. Then do some MRP, and then put your pencil down. Don't draw anything else on the diagram. How's it coming along? You guys have this thing diagrammed yet? Raise your hand if you'd like a little more time making your own diagram. Take another couple seconds. Does your Venn diagram look like that? All SRM, here's my S circle, here's my M circle. If all S's are M's, I'm shading all of the non-M S's away. I'm saying they don't exist. So I shade this region. What do we call that? 1, 2, 3, 4, 5, and 6. Regions 5 and 6 get shaded. And then I say some MRP. Some MRP. There exists at least one thing that's both an M and a P. Is it an S? Is it inside the S circle? Is it outside the S circle? I don't know. So I'd put it on the line. So make sure both that like you've got the crescent moon shape shaded out down here, and you've got an X or a star or whatever on the line in the intersection of M and P. Cool? Is that argument valid? Is that a valid categorical syllogism? In order for it to be valid, my conclusion would have to already be represented on my Venn diagram. But it's not already represented, right? It's not valid. Therefore, some SRP, there would need to already be an X inside the S circle that's also inside the P circle, right? Do I have one of these? I have that X. Is it a P? Yeah, this existing thing marked by this X, it's definitely a P. It is fully inside the P circle. Is it an S, though? I don't know. Yeah, there's something that's a P, and maybe it's an S, and maybe it's not. But I don't know for sure that there is at least one thing that's an S and also a P. So this is invalid. This is an invalid syllogism. And for those of us who like the chart method, we look it up. IAI1. Is it on the chart? Yeah, sure, don't look it up yourself. I'm sure somebody else will look it up for you. Regina, is it on the chart? IAI1? Nope, it's not. Well, I guess the rest of you better hope that we're not lying. Yeah, invalid. If you want to check your work, look it up on the chart. Want to try another one? EAE2. You can look it up on the chart to like check your work, but I would say try to do the Venn diagram first. No PRM, all SRM, therefore no SRP. And again, start with 3 circles. Minor term on your bottom left, major term on your bottom right, middle term on the top. And does it matter which of these premises you diagram first? It won't matter. They're both universal statements. You're going to shade for both of them. Raise your hand if you've diagrammed at least one premise already. Raise your hand if you've diagrammed both premises. Raise your hand if you'd like a little more time to do this diagram. Go for it. Take a couple seconds. If you are done, check this out. If you're not done, you can keep looking at your paper. If you're stuck, you can look at this as well. Is that what yours looks like? Yes? Some close, but close is not quite right on this. It's got to be exactly this. No PRM. There's my P circle, there's my M circle. If there are no P's that are M, all of the intersecting regions that are both P's and M's, they got to go. They get shaded out. And then all SRM. So everything that's in the S circle that's outside of the M circle, that's got to go too. So shade this. And I hadn't shaded that yet, so I'll shade that as well. Yep. So shade that region, that region, that region, and that region. That's no PRM and all SRM. And then I put my pencil down and I back up and I look and I see, is no SRP already diagrammed? What would no SRP look like? Yeah. In the intersection of S and P, nothing lives there, right? That would have to all be shaded. Boom, it's already shaded. That means this argument is valid. It is totally valid, and if you wanted to look up EAE2 on the chart, fingers crossed. Is it? It's there? It is. It's there. If you trust the people who say so, then yeah, EAE2 should be valid. You can check your work with that chart if you need to. One more? Yeah, one more. You got a worksheet too, but let's do one more up on the board altogether. AAA2. You can spoil it for yourself by looking at the chart, but I recommend doing the Venn diagram first. All SRM, all PRM, therefore all SRP, all universal statements. There won't be any X's on this at all. You don't have to worry about what goes first. Diagram all SRM, diagram all PRM, and then look and see, have you already diagrammed all SRP? Does your diagram look like this? Good. If it does, good. If it doesn't, something's gone a little bit wrong. All SRM says, here's S, here's M. I got to get rid of all the non-M S's. Shade that region out, shade that region out. All PRM says, here's my P circle, there's my M circle. I got to get rid of everything that's a P that's outside of M. So that one that was already shaded, why not? Shade it again, and then shade that region as well. That's all SRM and all PRM. What about my conclusion? All SRP. Is it already there? Nope. Nope. I still have some S's that are not P's and some S's that are P's. Or at least it's possible, right, that there are some S's that are not P's and some S's that are P's. So nope, I don't have it. Should be invalid. And I should be able to corroborate that on my chart. Can I? Yep, good. Yes?
Question about the slide that had IAI1, but we said it wasn't valid. The star was on the line, and so
That's right.
it's a possibility that maybe some SRP, like, would that be an example of conditionally valid?
That would, it would not be an example of conditionally valid. Like I said, yeah, we'll definitely look at that on Wednesday. If there's a little time, there are 2 on the worksheet that are conditionally valid. So we'll see that. But no, not this one is actually unconditionally invalid. This is definitely invalid, no conditions whatsoever. Because it's on the line, the way that we would end up saying is that if my 2 premises are true, then it's possible that my conclusion's true, but it's also possible that it's not. That ain't validity. That's something else, right? Validity is if my premises are true, my conclusion must be true, with no other additional information. What we're going to see with conditional validity is it's going to hinge on whether or not all of the things that I'm talking about actually exist. So there's going to be some kind of existential import. That's a weird enough wrinkle that I'll save it for just one day. So how are you feeling about this? Pretty good? Ready to tackle that worksheet? At least the first three. Let's get at least the first three done together. Start working on them now by yourself with your neighbors. We'll check those first three on the board here in class. And if there's any extra time after that, we can do more problems. Or if you want, you can just leave early. Cool?